Welcome to all. Myself, Dr. Vishwanath here, Department of UNC, Rajiv Institute of Technology, Hassan. Today, I'm designing and today I'm explaining and demonstrating the design and test of emitter following circuit using multi-sim. So you will have to know that what is emitter follower. Emitter follower is known as the common collector amplifier. The emitter follower is mainly used to provide the current gain and in impedance matching applications. The input of this circuit is applied to the base, and the output is taken from the emitter side. I will show in the circuit diagrams. Okay, and the voltage gain is always less than or equal to the one. Always it is less than one itself, and the output voltage is in phase with the input voltage. This is one of the specialization of this circuit. Okay, because this emitter follows the output follows the input signals, and the gain of this circuit is not the equal to one. We always it is say that less than one itself for now, and um, the output follows the input. That is that is called, we call this type of circuit, or this amplified is referred as the name of emitter follower rather than the common collector amplifier. Now, so this is the circuit diagram. So just observe the diagram. So here instead of output, we measure the output in where the collector side, we measure output in emitter side. Okay, the input portion is similar to for the common emitter and common collector configuration, but only the difference is in the output portion. The output is always measured in emitter side instead of collector sides. Okay, the circuit here we are using here voltage divider circuit R1 and R2, and two coupling capacitor we use it C1 and C2, and the transistor we use N type of transistor we are using. Okay, so here it is a NPN transistor, and emitter resistors are connected to the emitter side. Outputs are measured across the load resistance of the emitter. Now, I told that already. The difference between the emitter follower and the conventional amplifier is the absence of collector, load, and emitter bypass capacitors. So here the load is it's the absence of load in collector side. Collector we are directly connected to the VCC without any resistance in the emitter follower. And the emitter resistance RE itself acts as the load, and the AC output voltage Vout is taken across gate. And the biasing is provided on either by base resistor method. Instead of RB, we are using here voltage divider circuit R1 into R2, and or it is a potential divider method. And circuit consisting the resistance of the order of 10 kilo ohm in the emitter itself, and the collector connected directly to the supply. To stabilize the operating point is exponentially good because of high value of the emitter resistance RE. So we are selecting RE is a high value, and these are the emitter follower design following procedure. First we choose the transistor, select the emitter resistor, determine the base current, determine the base voltage. So base current and base voltage and base resistor value, and determine the value of input capacitor value, and determine the output capacitor value. So this is our practical circuit we are using. So base voltage divider resistor values are R1 and R2. R1 is 22 kilo ohm, R2 is 33 kilo ohm, and coupling capacity C1 and C2 are 1 microfarad we are using, and RE resistor is we are using 2.2 kilo ohm, and the transistors we are using it's a NPN transistor BC107 BP connected to the signal generator. Okay, and for measuring purpose we use oscilloscope. Okay, schematic connection, the channel A is connected to the input side, channel B is connected to the output side, and load resistance we are using 1 kilo. This load resistance value can vary, depends upon the circuit intent. Okay, the design pattern, the resistance, load resistance are there. And this is the expected output for waveform. So input is and outputs both are is in phase and almost equals. So there is from the observation from the screen you observe that both input and outputs appear like a same. Okay, there is no phase shift, phase difference in both input and output. So almost the gain is 1. Okay. Now we go for the multisim. For the demonstration purpose, I am using multisim software. So go to the multisim. Okay. So this is the circuit already connected. Okay. Just for the practice purpose, I will show how to connect the circuit connections. So before that, I will explain that circuit. So here R1 and R2 I connected, and there is RE resistance 2.2 kilo ohm I am using. Now, just for design, go to the design, select the new window, and place the component purpose. So place component or use Control W, the shortcut. So transistor, select, go to the transistor. So BC107 I am using. So select it and place it. Then select the resistors. So basic, go to basic, resistors. Okay, so 22 and next 33 and 0.2 2, okay, and 1K, just I use 1K. Next, select the capacitor. So instead of capacitor, we are using electrolyte capacitor. Select the electrolyte capacitor, 1 microfarad, and two capacitors we needed. Okay, then ground. Then we need signal generator. Okay, signal generator. So we selected here with the wattmeter, function generator, and for measuring purpose, oscilloscope. Select oscilloscope. Okay, so now we need to connect all these components. Just rotate 90 degree. Select and rotate the 90 degree of the comp. Okay. And one more component we need for biasing purpose. So DC source. So select. So now establish the connection through the wire. Okay. So no collector resistors are there, and DC supply. So input, just I flip the vertical, sorry, not horizontal wise, I will, because plus wire I connected. It's very easy to connection purpose. I will just horizontal the, flip the horizontal of this signal generator. Channel A I connected to the input and ground. Channel B connected to the output. Okay, so I change this. Right, input line. I change input line from red color to blue color. Okay, okay, and change the value of signal generator. So select the sine wave signal. Frequency is 1 kilohertz, and peak to peak voltage is 12 volt. Sorry, 2 volt. Peak voltage is 2 volt. So enough, not needed for 10 volt. Now we need to run this. Need to run. After that, save the circuit connection. Emitter follower I already saved. I give one more name. Emitter follower. Demonstration. So then after save, run this. So just double click on this. Stop. Okay. Just change for clear visible. 1 milliseconds is better, and 5 volt. Oh, but observe that input is blue color. Input signal is blue color. Output is is red color. Some changes in the negative off cycle. So just I will improve the load voltage, load resistance value. Yes, I got exactly. So better we choose, instead of 1 kilo ohm, choose 10 kilo ohm is sufficient value. Okay. Okay, I hope you all of you understood the design and testing of the emitter following, circuit connection, and the output waveforms. Okay, in the output waveforms also observe that the output follows the input values without any changes. The gain is also equal to 1. Thank you for watching.